So, all right, let us get into your argument about the hazard of our current vaccine regime. And let me say, you have made some very strong claims. You have argued that, in fact, the vaccine campaign that we are currently engaged in is so dangerous that it should be halted. And I will say, I don't know if you're right. I cannot determine based on what I understand if you're right. But what I can say is that you are making sense, right? This is frightening in and of itself, that your argument is completely coherent. Whether or not it is true, this is at least a question that should be engaged by those who are making policy around this, because the possibility of making our viral situation with respect to COVID worse is present. And, we are creating the hazard of the future that we will be confronting a year or two down the road by our actions now. And so were we to have reacted differently at the beginning of COVID, we might not be in the situation we're in now. Were we to act differently now, we will be in a different situation years down the road. And so we are always sort of setting the stage of our next battle. And it is in that context that we have to engage your argument and take it quite seriously. So what, in a nutshell, is your argument for the hazard that we may be creating?
So my argument is, first of all, as I was always saying, these vaccines would be perfect to be used outside of a pandemic. Why I'm saying this? Because if you use vaccines before you get exposed to the virus, well, in this case, it's a virus, you can build a full-fledged immunity, as you were pointing out, Bret. This takes time. Most of the current vaccines even require 2 doses. You have been pointing out about this clonal expansion. In the meantime, you acquire memory, you acquire higher affinity, etc. This is a process before you acquire the full-fledged immunity. So if you have this full-fledged immunity and then you get exposed to the pathogen, you literally have everything you need to fight off this pathogen, right? And there is absolutely no problem. And that's what I have always been saying. I'm not talking about maybe secondary effects or adverse events, etc. This is not my field of specialty. Other people can discuss this. So I'm not talking about really the quality of the vaccines or adverse events. But in principle, this is a correct vaccine to be used outside of a pandemic.
So let me just pause you there. Let's say, just hypothetically speaking, let's say that the virus had emerged in Wuhan and the world had limited its spread. Let's say that it was kept to Eurasia and the rest of the world had not faced the virus. Then, if we took one of these mRNA vaccines, for example, and vaccinated the population so that 80-90% of the population was vaccinated before encountering the virus, before the virus crossed any ocean, for example, then we would expect this to work very well.
Sure.
And the hazard of it would be low, even if it was true that it only produced, let's say, 80% immunity, and even if it was true that some people who were vaccinated but then became infected did shed some virus and occasionally infected other people. Is that fair to say that this would still be a reasonable campaign?
Yeah. The only thing I would like to add, Bret, just to be clear for the audience, is that here we are talking about the original virus, about the wild virus, the original Wuhan virus, right? We are not yet talking about variants.
Right.
So, under that assumption, what you're saying is perfectly correct and fine, because even if you don't prevent infection completely and you diminish only the viral load, as long as the virus will not have enough opportunity because the infectious pressure is so low to propagate, it will die out. So that is perfectly fine, and so you can control it.
So this is the thing that I think is too subtle for most people to get, and hopefully we can help them see the difference. The vaccine, from the point of view of the patient goes, they go through whatever anxiety they have about needles and unknown hazards of vaccines, and they get their shot. That looks the same to people, whether they're being vaccinated in the midst of a pandemic or in advance of a pandemic. But from the point of view of the evolutionary landscape, these two things are completely unrelated, right? Introducing the vaccine when the virus has already gotten a foothold and has started to diversify. Getting a vaccine is actually, it's like showing up. Imagine that your nation was being invaded, right? And there's a question about how useful your rifle is when the ship, some little boat with 12 people on it shows up on the shore. Your rifle might be very useful, right? If you show up with that same rifle against an army of 10,000, you're going to get shot. And, you may actually be in a worse position because you'll give away, you're shaking your finger.
Especially if this happens before you can completely charge your rifle. Your arm is not fully charged and you are already under attack.
Right, already under attack. So this is, in some sense, this is very straightforward to me because I'm used to thinking in evolutionary terms, right? And so the idea of, to me, the virus looks very different, even though the particles may be very similar to each other. The virus looks very different when it has a huge number of individuals in which to engage in evolutionary experimentation versus a tiny number of individuals where the chances of it happening on anything useful are very small, right? Once you've got the huge canvas, the chances that the virus is going to learn new tricks are 100%. And in fact, it's doing it. And, as I said at the top, no surprise at all that us having botched the initial reaction to the virus, which frankly, in my opinion, should have been much stronger, right? We should have had a much more intensive campaign to control the spread of the virus early on, and we might not be dealing with this, half-assed, long-term, set of measures that are increasingly draconian and having all sorts of other effects. A short, intense control effort would have been more effective. In part, the reason that I say that is because it's just much easier to address, if this was an invasive species and there are 10 individuals, right? Finding them is very effective. You can find them, you can eliminate them, you're done. Once the thing has covered the landscape, it's a whole different puzzle, even if the individual critters aren't very different. So, all right, we've got a difference between these vaccines and their utility in advance of a pandemic versus in the pandemic. We are in the pandemic, and now what do you see the hazard being of a mass vaccine campaign?
Well, Bret, so these vaccines will definitely induce an immune response. That's what we have been explaining. So what we know is that it takes time to develop an immune response. So during that time, your immune response is not optimal, right? It's not fully mature. That is one thing. The other thing is we are already dealing, before we started the mass vaccination campaign, before they got rolled out properly, we had already variants. So again, the immune response that you are mounting when you have been vaccinated is suboptimal towards a variant that has a spike protein which is different from the spike protein in the vaccine. So the vaccinal antibodies against the spike protein are suboptimal because the S protein of the variant is not the same. So we are, when we are vaccinating people, as I was saying, you are going to war, but your arm isn't charged yet. You are already fully under attack and you still need to mount this antibody response. And you are attacked by things that you have not learned to properly recognize. So the immune response is suboptimal. So now, So this creates what we call an immune pressure. It's definitely a pressure on the virus. The virus isn't happy with his immune response. But it is going to be able to adapt to that immune pressure. Why am I saying this? I'm saying this because whenever you have to adapt a virus or a microorganism, but I'm talking about viruses, to unfavorable conditions. Let's say you would like to do this in the lab. You have a virus and you would like to adapt the virus to an unfavorable condition. That unfavorable condition could be cultivating, for example, an influenza virus on eggs instead of on a cell culture, or incubating your virus on a temperature that is not ideal for the cells to grow and for the virus to produce. But it could also be, the unfavorable condition could also be an immune pressure, antibodies, for example, that are present. So if you would like to do this in the lab, you would like to adapt a virus to unfavorable conditions. What you would do is you would take that virus and you would put it on a cell line in the presence of those unfavorable conditions. So in this case, it would be a suboptimal antibody dose, let's say. But then that is not sufficient because, of course, you have always, and that is the argument of many people, you have all the time variants and mutations, etc. Of course. But now you will select certain mutations that are capable of dealing with this unfavorable condition, right? So you will select those variants. But that is not sufficient because it's not because you have done this selection one single time that this variant is now going to become dominant in the population. It will still have a very low, we call this a viral titer, a very low concentration. But now if you take that virus or all these viruses and you're now going to inoculate this on another cell culture under the very same conditions of immune pressure, and then you do it again and again and again, then ultimately this mutant will adapt to these unfavorable conditions and it will have a competitive advantage compared to the original viruses. And that is how, in the course of time, this population of these mutants that originally were only present in very low concentration will now become predominant. So now you extrapolate this to people. What you're going to do in order to be able to adapt a viral mutant, you would need to passage a virus from one person to the other. But in order for that virus to be able to adapt, it would be important that these people are under the same immune pressure, also experiencing a situation of suboptimal immune response. And what I'm saying is that if you're already having variants before you start your vaccination campaign, and then you're immunizing in the heat of the pandemic, where while the immune response is built up, you're already under attack. Many people, of course, in such situation are going to be experiencing a suboptimal immune response. And hence this will enable mutants that occasionally emerge, of course, to adapt and to gain a competitive advantage and to become dominant in that population. And then, of course, we have a problem because this is what we call selective immune escape. You select it and you enable the virus to adapt to that situation so it becomes predominant. And that is what we are seeing right now. As soon as you have an infectious variant popping up, guess what? I mean, it takes like a few weeks or it becomes predominant in the population.
Okay, so let us build on the analogy of war to see your argument more clearly. When we send soldiers to war, we send them to boot camp first. Okay, boot camp is like the vaccine, right? We expose them to something that is warlike without there being an actual enemy, so that the soldiers can learn to fight that enemy in a comparatively safe context before they face the actual enemy. If you send your soldiers to the front before you send them to boot camp, not only will they be vulnerable, but they will end up training the enemy on how to exploit their weaknesses, right? You want to eliminate the weaknesses first. And so in effect, what you are saying is that by deploying this vaccine in the context of an epidemic already underway, we are effectively sending soldiers to the front. And we are, yes, it is true that the soldiers will learn to fight on the front to the extent that they can survive, but they will also teach the enemy to fight even better. So you are entering an arms race at a disadvantage rather than an advantage. Now, if we extend the metaphor a little bit, let's imagine, so the whole system functions based on the ability to recognize the enemy and see it very clearly, right? And you could imagine on the battlefield, this would make sense too. To the extent that some enemies are very good at camouflaging themselves, those enemies tend to persist. To the extent that some enemies are obvious, they tend not to persist because they get shot. So imagine that we did some trick with the camouflage that the soldiers on the front wore, where those that persisted the longest, their camouflage spread itself, and those that died early, their camouflage went extinct, right? So over time, the camouflage would get better and better. By exerting this pressure, you are arguing, and I think there's no question that this is accurate, we are effectively running what would in the laboratory be called a serial passage experiment. We are creating those exact conditions in a context where there's a huge landscape of virus already adapting to the inability of the immune system to see certain things. And I would add one thing to your description so far, which is that the nature of these vaccines, part of the magic of them, the ability to generate them so quickly, has to do with how utterly narrowly focused they are. Instead of doing something traditional like taking a virus and inactivating it and introducing the whole virus into the body so the body sees the whole thing, right? We've narrowed the focus down to the spike protein itself. And not only that, we've narrowed it down to the spike protein of the original virus. And this has created a very concentrated pressure, which means that we're trying to inform the immune system of exactly what the enemy looks like. And we've honed in on one characteristic. And that means that if the virus can change that one characteristic, then suddenly it becomes invisible. And so we are effectively setting ourselves up for an evolutionary failure by concentrating our response and introducing it on the front rather than in advance of the encounter. And, again, I don't know that your argument is right, but I can say it's very clearly plausible and the hazard is potentially immense.
So the thing I would like to add to this, Bret, which is a very objective argument, we absolutely need, because otherwise we, not the both of us, but the community is going to turn around in circles. And of course, I can understand that the resistance is enormous, but we absolutely need criteria that we agree upon that would enable us to distinguish whether human intervention, whether this is mass vaccination or the mass prevention, infection prevention measures, are both combined, induce immune escape. So what would be the criteria that would be generally acknowledged and accepted? Would this be, for example, dramatic increase of more infectious variants, for example? Would this be resistance to the vaccines ultimately? Would this be that we have more and more younger age groups that become infected? So there is a number of criteria that could be defined and that, according to my humble opinion, clearly illustrates that there is a huge impact of human intervention on the way the virus evolves and on the collective immune response of the population and the dynamics thereof. But as long as we don't agree upon this criteria, my fear is that mass vaccination will continue no matter what till everybody gets vaccinated. It's no longer a question of immune defense, building an immune defense. It becomes a question of vaccinating everybody, which is not the same, certainly not within the context of this complex phenomenon, the pandemic, combined with human intervention.
Yes. So I like what you're saying very much about the criteria. I have a concern or two. Some of the criteria are likely to occur either way. So, for example, let's just take one. You talk about the potential for the increasing vulnerability of the young. And we have not yet described why it is that the young might be anomalously immune to COVID, which they seem to be. We'll come back to that. But one thing that is certainly true is that the young, to the extent that they do not seem to come down with COVID, and when they get it, don't seem to have very severe disease in general, represent an opportunity for any variant that can figure out how to bypass effectively what must be their innate immunity that is preventing the disease. So that opportunity exists whether we vaccinate or we don't. And it is, in fact, one of the reasons, the argument that I would make for a very intensive campaign of behavior modification to control the virus, which, the ship has sailed, but we should very early on have treated this much more carefully, because now that it is out in the world in such large numbers, there is nothing to stop it from discovering a pathway to infect the young, right? It is always hovering at the door, and it may eventually figure out how to accomplish that, just as it may eventually figure out how to spread outdoors, something that it does not seem to do well yet, but is an opportunity, to the extent that some of us are using the outdoor environment effectively to engage in social behavior because the environment itself protects us. That's an opportunity if the virus can figure out how to endure UV light or whatever else it's doing. So how many of your criteria will separate the natural evolution of the virus just by virtue of the fact that we have an uncontrolled pandemic from the evolution of the virus driven by a targeted broad-scale vaccine campaign?
Well, that is exactly what the criteria should be based upon. And I guess the only comparator we have, unfortunately, is almost like the flu pandemic, 1918. Why I'm saying this? Because this was clearly a pandemic of a respiratory virus where there was no human intervention. Infection prevention measures were very, very, very limited. It was war on top. So you had crowding, you had very bad hygienic conditions, etc. And there was no vaccine. So there, first of all, what we have seen no variants. The whole thing happened within 1 year. And people have been sampling or analyzing autopsy samples to see whether there was any variation in the strains that, during this pandemic appeared in several different parts of the world. And it was very homologous. So that is one thing. Now, so that is very important, because this is a high infectious pressure, a natural pandemic, no human intervention. So if you imagine now that we have, like, every second or third week, we have a new infectious variant appearing. And not only is this a more infectious variant, it's very often also much more infectious, like the Brazilian compared to the UK, etc. And it all appears very rapidly. It's not like during evolution, of course, these things appear, and if they have a competitive advantage, they will replace the original strain. Now, all this is happening, multiple variants within a short period of time with dramatically increased infectivity. And this in parallel with the mass vaccination campaign. I mean, as I was saying, you have the same pandemic. Well, it was flu, of course. Nothing happens in terms of variants. There were a few mutations, but here the mutations are very clearly targeted. They are selected at domains that enhance the infectivity virus. So they are not like random. They are really selected towards parts of the spike protein that are responsible for infectivity. So, I mean, there is something there, right?
Oh, yes.
As I was saying, we need to agree upon this. Same, for example, if you imagine now the situation in Chile, for example. Okay, so you're vaccinating on a background of a variant that had just appeared, right? I mean, the Brazilian variant. So this Brazilian variant is, of course, pretty much different, the S protein, from the S protein of the vaccine. If you now start vaccinating people, of course, this variant that just emerged is going to have a competitive advantage because it's more infectious. And what you want to do with your antibodies is to prevent infectivity. So now all of a sudden you see how this variant is exploding and you see the infectious rates that are dramatically increasing. So all of a sudden you have a much higher infectivity rate, right? And so there is other criteria as well that we could, the mutations are of course studied. We see more and more that they are also now converging towards domains that are targeted by the vaccinal antibodies. So if you take all these things together, we should be able, compared, as you pointed out correctly, to a natural pandemic, to observations that are really high, very, very strange, and that, according to my humble opinion, could be correlated with at least, I would say, human intervention, right, in this pandemic.
So if I can make that a little bit simpler, what you're saying is, A, something that surprised me the first time I heard you say it, which is that in the 1918 pandemic, there were no widespread variants, and we know this from the comparison of samples taken during autopsy. So that shocks me. I think what it suggests is that the evolutionary experimentation took place before the pandemic, that effectively the virus got very effective at transmitting in some small population that wasn't captured in the autopsy samples. Maybe it wasn't even recognized as a unique disease. And that by the time it circulated around the globe, it was already highly effective. And that in this case, we have, well, I would say the anomalous fact of this virus apparently having emerged in the human population already highly effective. We have no evidence for that experimental evolutionary period at the beginning, which is one of the reasons that many of us believe the laboratory origins hypothesis is probably correct.